Welcome class. Thank you for joining me for our 4-6 notes. Now we are going to start a completely new type of way of solving quadratics. So we are continuing the idea of solving these. First, we talked about graphing, then we talked about factoring. Now we're going to move on, and today we're going to cover two more ways of solving quadratics. Now, the lesson is called completing the square, but before we get there, there actually is another way that we're going to cover first, solving by square roots. So we use this method when the equation doesn't have the x term in it. It only has x squared and a number. So the a term and the c term. And just to give you a visual what that looks like, we're going to be talking about that. Notice there is no bx term in there. That's what we can use solving by square roots. Now, what does that mean? How do we solve it this way? Well, what you're going to do is you're going to isolate the square root term. Okay, so you're going to get the square root term by itself, and then you're going to square root both sides. And when you do that, make sure you're putting the plus and the minus symbol for your solution. So to describe or to show you what that looks like, x squared minus 81 equals 0. Well, again, the first thing we want to do, we want to isolate that square root term or the squared term. So I'm going to add that 81 to both sides to get x squared equals 81. Next, to get rid of the square, we are going to square root this. So square root both sides, and you get 9. However, I want you to realize that really we know in quadratics we should be getting two solutions. So when you take the square root to solve these equations, I need you to take the plus and the minus, because 9 squared will give you 81, but negative 9 squared will also give you 81. You need both of them. So moving on to our next example, 2x squared minus 72 equals 0. Well, our goal is still the same. Our goal is to isolate that square root or the squared term. So I'm going to start by adding the 72 over to the other side. Now, this time I also have to divide by 2. So I divide both sides by 2. And now my squared term is completely by itself, so I am ready to take the square root. And again, remembering when I take the square root to solve an equation, I'm getting both a plus and a minus in my solution. Moving to our third example, looks very, very similar to the last one we just did. I'm going to add that 150 over to the other side, because again, my first goal is to get the squared term by itself, divide by 3, and now square root both sides. Now, in this case, I want you to notice that square root of 50. Think way back to exponential algebra. And we learned how to simplify those things, okay? We know how to simplify radicals. So when you get a not nice answer, such as the square root of 50, I want you to think, can this be simplified? And remember, in order to simplify them, you need to identify the greatest perfect square that can divide it. In this case, 25. Because remember, you can pull it apart. So 50 is 25 times 2. And why did it just pull out that perfect square? Well, because the square root of 25 is just 5. So this is our truly simplified answer, okay? So whenever you're getting square roots for these, when you don't get a perfectly nice answer, I do want you looking to see, can the square root simplify it all? So that's how we do what's called solving by square rooting. Now, the real focus of today is completing the square. Completing the square can be used if you can't factor and you can't use square rooting. Okay? So, completing the square, you have to create a perfect square trinomial. To do this, you have to add b divided by 2 squared. So again, what we're talking about is y equals axb or ax squared plus bx plus c. And in this example, I apologize. Could you please fix that? That should be plus a 6x, not just a 6 for our example to work. So when you get something like this, so notice we have that x term now in this example. Okay? So right now we have x squared plus 6x, and they want to know what number completes the perfect square. And again, to complete the perfect square, we need that value. Remembering b is a number with the x. So in this case, our b is 6. So to complete this perfect square, we have to take that b value, so 6, and divide it by 2, and then square it. So we get 3 squared, or more commonly known as 9. So notice what happens. Why do we choose that 9? Well, because with that 9, notice, how does this factor? Well, it factors into that, correct? And the reason we want that is because we want something that can be written such as that. That is a perfect square trinomial. All right, so that's why it is so important that we seek out that 9. How do we get it? We get it by using that. So again, it's going to take a little bit of practice. This is something really new to you, something you haven't seen before. But once you get the hang of it, it is not too terribly difficult. So let's step through how to use this process. So we're going to solve by completing the square. So when we're solving by completing the square, the first thing we're going to do, move the constant to the opposite side of the equation. So we want the x squared and x terms together. We want to move the constant to the other side. So what that means is I'm going to change my equation to look like that. I'm going to subtract the 2 over to the other side. Next, I'm going to add that b over 2 squared to both sides of the equation. So my b is -4. So I have -4 divided by 2 squared. So that's going to be -2 squared, or just a positive 4. Now, you know, we can't just put it on this side of the equation. It doesn't work that way, okay? We have to add it to both sides of the equation. So notice, once I find that term, I'm going to add it to both sides of the equation. Because, again, if you add it to just one side, now you're altering the value. So, step 3. We want to factor that perfect square trinomial. So we need to factor that now. And when you do, you should get that that is x minus 2, x minus 2. Right? Two things that multiply to 4 and add to -4. So what ends up happening is we get x minus 2 squared equals, and over here, -2 plus 4 is going to be a positive 2. So that's why we're looking for these perfect square trinomials. We need to be able to write that binomial as a squared. Now it says square root both sides. So to square root both sides, well, a square and a square root, they undo each other. So on this side of my equation, I only have the x minus 2 left. On this side, when I square root that 2, I'm getting a plus or minus square root of 2. So again, the next important thing to know is square rooting undoes the square. And it's important to remember you're getting a plus and a minus. That's how you're getting your two solutions. Now finally, to solve this, I'm going to add that 2 to both sides. So I'm getting 2 plus or minus the square root of 2. And that represents my two solutions to this quadratic. Now again, please just kind of bear with me as we work through a couple more examples so you can really get a feel for how this works. So again, our goal is to solve by completing the square. So I'm going to start by moving the constant. I'm going to move that negative 6 over to the other side. So 2x squared minus 8x equals 6. Now the next thing to know, the little tidbit, is the x squared term must be by itself for this to work. Okay, so what that means is because of that 2 that's with it, I need to divide this whole equation by 2. It's the only way that this process can work, is I absolutely need that squared term by itself. So there can be no coefficient with the x squared. So once we have this, now we look at that b over 2 squared. So negative 4 divided by 2 squared. That's going to be negative 2 squared or 4. So that's telling me I need to add 4 to both sides of my equation. Now, you saw this last time. This factors to x minus 2, x minus 2. So to write that as a perfect square trinomial, that's just x minus 2 squared. Then on the other side of my equation, 3 plus 4 gives me 7. So again, the whole point of this process is trying to get that perfect square trinomial to equal a number, because now I can solve it. Now when I take the square root of both sides, now I just have x minus 2 on that side. But remember, on the other side, I'm getting plus or minus, and then the square root of 7. So when I go to solve it, I need to add that 2 to cancel it off. So I get my x equals 2 plus or minus the square root of 7. And again, that represents my two solutions to this quadratic. So let's step through one more example together to really get a feel for how this is working. So again, solve by completing the square. So looking at this, first step, get the constant by itself on the other side. So negative x squared plus 6x equals negative 3. Now, notice, I emphasized last time that the x squared term needs to be by itself. Now, that means there can't be a coefficient with it, and that also means there can't be a negative with it. So just like that previous example, because there's a negative there, I'm going to divide by that coefficient. Well, dividing by negative 1, all that does is flips the signs of everything. So picture dividing the whole thing by negative 1 to flip the signs of everything in the equation. And the reason we're doing that is because we need the x squared term by itself. What's the next step? Well, the next step is looking at that negative 6 and saying, all right, I need to get b divided by 2 squared. So negative 3 squared or we're talking about 9. So I need to add 9 to both sides of my equation. And hopefully you can see, how does this factor? Well, the two things that multiply to 9 and add to -6 are -3 and -3. So writing this as a perfect square trinomial, you get x minus 3 squared. Now, realize if you don't get the x minus 3 squared, what that's telling you, without that perfect square trinomial, is telling you that you did something wrong. So every time you should have a setup that looks like this in order to solve it. Because what do we do now? Well, now I'm going to square root both sides. Again, square rooting undoes the square, so I just have the x minus 3 left. Then plus or minus the square root of 12. Now this time, I want you to note something, okay? We're going to do a little scratch work over here. So square root of 12. Is there a perfect square that goes into that? Remember this list of numbers from your first slide. There is one that actually goes into 12. That 4. So the square root of 12 is actually 4 times 3. Why am I writing it that way? Well, because square root of 4 is 2. So right away, I'm actually going to call the square root of 12 2 square roots of 3. Remember, I do want you simplifying these, okay? Simplify your radicals. Now, to solve, I'm going to add this 3 over to both sides. So we get 3 plus or minus 2 square roots of 3. All right, so that is going to be all for our notes today. Thank you so much for joining me and watching these. Please make sure you have all of this written down, and then please make sure you bring it back to class so we can work on our practice work together.